Hello everybody, welcome back to Retro Computing Ranch. Today let's talk about ROM. Read-only memory is ubiquitous in all types of electronics, but how does it work and how can we make use of it? Let's dive in and take a look at the practical and the esoteric aspects of read-only memory. There are many types of ROM, anything from core rope memory through diode matrix ROM, uh, one-time programmable ROM, UV erasable ROMs, double EEPROM, which is electrically erasable programmable read-only memory, flash ROM, and others. I'm going to focus today on one-time programmable ROM and UV EEPROM, as you'll see those most commonly in vintage and retro computers. While one-time programmable and UV erasable electrically programmable read-only memory have a lot in common, we should start with the differences. So one-time programmable ROM is one-time programmable. You can only program it the one time, and then after that you have to discard the device, get a new device. UV erasable programmable read-only memory has a window in it that's transparent to UV light. And if you expose the ROM to UV light in the appropriate frequency range, it will erase the ROM, and then you can reprogram it electrically again. Now, there are limits to how many times you can do that, to how many times you can erase the device, to how many times you can program the device, and so it's something to be aware of. Now, the way that this is done is with a technology called FGMOS, which is a floating gate metal oxide semiconductor. So what they do, and I'm showing it here on the screen, is at the base they have an N-channel MOSFET with a source and a drain. Above that, they have an oxide layer as an isolator. They have a floating gate that's not connected to anything. They have another oxide layer, and then they have a control gate that is connected. So what happens is when the device is programmed, usually with a higher voltage and specific timing, which the programmer needs to support, the electrons are stored in the floating gate. Since the floating gate is not connected, those electrons stay there even if the device is powered off. What that allows you to do is when a computer or a piece of electronics is powered on, it can read through the array and determine the state of the gate as to whether it's a logical 0 or a logical 1, and then use that to load code, microcode, firmware into the device to get it started. Now, on one-time programmable ROMs, they actually use the same technology, and the only difference is that those devices lack a window. So if a one-time programmable device had the quartz window, you could expose it to UV and erase it just like a UV erasable EEPROM. And that's part of the consideration there is it's cheaper to produce a device encapsulated in plastic and to not have a window. So that's why they make the one-time programmable device. Continuing on, the UV source that you need to use to erase a UV erasable programmable read-only memory should be around 250 nanometers in frequency. That is in the kind of standard germicidal UV lamp range. Those lamps can be found online. You can buy a purpose-built UV ROM eraser with a timer. You can get them used or new from various sources, eBay, Amazon. Now, what I've done in the past, my first UV EEPROM eraser was a toothbrush sanitizer that has been modified to no longer use batteries. I can just plug it into a 9-volt source and use it that way. And I've used this for probably 15 years, 20 years. Now, what I picked up recently is a USB-powered phone sanitizer. Picked this up, I think, at like CVS or Walgreens, something like that. And it has a germicidal lamp in it as well. Now, it is small. You're only going to erase maybe 3 or 4 chips at a time. But even on my other eraser, I never erased more than 3 or 4 ROMs at a time. The great part here is that it hooks up with a standard USB cable. And on the top, it has a timer, which I'll have to throw a picture in of that. It can be set for 5 minutes, 15 minutes, or 30 minutes. I find that most ROMs will erase in 15 minutes, although sometimes if the ROM window has been damaged, you may have to go as long as 30 or multiple rounds of 30. to get it to erase. So that phone sanitizer has a listed frequency, and I'll put a picture of this as well, of 185 nanometers. I've erased plenty of ROMs with that device. The only thing that you'll run into is the lower in frequency that you get, the more ozone that it makes. So when you open it after erasing ROMs, you will get a strong odor of ozone if you're using something like this that's lower in frequency range. Really anything below 250 will generate ozone, but the further down you get, the more ozone that it makes. So just be mindful of that. So on an EEPROM, a UV erasable one, what you'll want to do is make sure you have a label on it. If you do not have a label on it, any UV that gets to it, whether that's through a ventilation hole or a gap in the case or whatever, over time will erase these devices. So put a label on that is opaque. Now, when you go to erase them, you'll have to take that label off. Now, I have run into this quite frequently. I have bought large EEPROMs online. If you harvest parts, you'll come up with tons of the smaller ones, 2764s, 27C, 128s, 27C, 256s, 512s. If you need something larger, like say a 27C 801 or a 27C 080, about half of the ones that I buy, the window on them is damaged because people remove the labels incorrectly. So what they'll do, apparently, because I wasn't there, is they'll get like a razor blade or something, and they'll scrape that label off. In the process, they'll scratch or scrape divots out of the top of that window. What that does, and I'll put a picture up here, is it makes it hard to erase the ROM, which leads to you running it more times through the eraser. Now what that does is the harder and longer that you erase a UV EEPROM, the more damage is done to these isolators. And once that oxide layer is gone, you'll either end up with a logic cell that you cannot program or a logic cell that's stuck. You can't erase it and you can't program it. So just be careful when you take these off. Now what I do is, and I'll grab a little picture or run a little video over to show. All right, so I'm going to show you how I remove the labels from the top of EEPROMs without damaging the transparent window. The way that I do that is with some heat. You could use a heat gun. I have a hot air rework station here. I'm going to turn this on. Now it will get pretty noisy, so I don't know if you'll still be able to hear me or not, but let's see what happens. Alright, so I'm going to make sure I do have hot air coming out. I'm going to start heating the label with the hot air gun. What this is going to do is soften the adhesive. So even if this label has been on here for, who knows, 20, 25, 30 years, it will still soften up with application of heat. And then we'll be able to remove it without a lot of undue scraping. I think that should probably be about enough heat. Let's turn the station off, let it cool down a little. And as soon as it shuts off here in just a moment, once it reaches the set temperature, it's dropping, then I will be able to scrape this label. Let me go ahead and start on that before it starts to harden the adhesive back up. All right, and that IC is warm. Be careful. You might even have to use an additional tool. Can't touch it for too long. But as you can see, that label is coming right off. No scraping. Let me set this aside here. And then if you look, you can see that the window is pretty clean. There's a little residue on the top, but there's not really much on the window. You can come back and hit that with just a little bit of Goo Gone, and that should clean it right up, or even some strong isopropyl alcohol, 91% or better. Should take care of that, no problem. And then you're ready to get it into the eraser. So there we go. You'll usually have a little residue left on top. What I do to take care of that, what works most of the time, is citrus-based Goo Gone. It will, with a little bit of work, take it off. You might have to scrape a little bit more. Just be careful not to scrape the window. If you have a label that's really stubborn, you can use something like Goof Off, but you have to be very careful. So one, Goof Off is pretty aggressive. It can work its way into the device and cause all kinds of problems. Also, there's a lot of vapors from this, and they don't smell real great. And I'm sure they're probably not good for you either. So just be mindful of that. Once you've got the device erased, you'll put it into the eraser, and you want to make sure that the window on the device is lined up with the light source and it's as close to it as you can possibly get without touching it. I also forgot, you can also use isopropyl alcohol. Just make sure it's like 91% or better. And with a combination of all of those, you'll be able to get that label off. Now, when it comes to programming, there are various programmers out there that you'll hear a lot about. There are legacy older devices. You might be able to find one on eBay that works. A lot of them are slow. They also have a lot of compatibility problems. They're slow. They have a lot of compatibility problems. And some of them just don't work very well. Now, you may get into a situation where you do have to have one of those. If you want to program a very old, very small ROM, like say a 2708 or 2716, you may have to track down a very old programmer to do that. I have a Contron MPP80S, which handles those devices. It's actually in the process of being repaired. That'll be in a future video. I almost never have to program devices that small. In the past, I've had other devices like a Willem. My current device is a TL866. There's a lot of support built into those. You could take a look online at the list of compatible devices and find out if it supports the devices that you're going to be working with. Now, the other thing I like about the TL866, mine's an A. I think the current version is the CS. They have a logic test, so they'll test like 7.4 series logic and certain SRAMs, which is great functionality to have. I've had homebrew boards before built on 7.4 series logic that I was trying to track down issues, and I used the logic test feature on the TL866 to test all the logic devices, and I found a couple that didn't work, replaced them, got the board back to working. So that's another great thing to have on your programmer. Now, the software that comes with it is Mini Pro Programmer. You get that from the vendor and install it, and then you are able to check your device ID, read the device, save the file, load the do a blank check, and then load your ROM in, your bin or your hex, and dump it to the device. So let's take a look at how to do that. Give me just a moment to get set up, and we will be right back. All right, we're back again. So I have the Mini Pro software open, and I have the ROM file that I want to program here. So the first thing that I need to do is I need to click here and tell it what device that I have. Now, I know from looking at the label on this device that it is a 27C 801. And I also know that it's made by ST because I can see the manufacturer's mark on it. So we're going to select that, and then we are going to open the ROM file that we're about to program. If we can find it here. I have too much stuff on my desktop. There it is. Okay, so all of this is fine. The defaults are usually fine. If you run into a situation where you need to change something, you're probably going to know. Just keep an eye on it. All right, we're going to hit OK. And we can see that we've got our file loaded here. So the first thing that I'm going to do is I'm going to do a device ID check. Oh, you know what I have to do? I have to actually plug the programmer in. This is the programmer, by the way, the TL866A. I'm going to plug it in. it will detect. And then I have my 27C801. You can click on information and it'll tell you how to insert the device. Make sure you have the notch up at the top where the ZIF lever is at. So I'm going to click the X there. I'm going to open the ZIF lever. I'm going to insert the device into the programmer. As you can see, the device is inserted. I've closed the ZIF lever, which means press it down. So I'm going to check device ID, and I can see that it pulled a device ID. Now, if you do that and it shows 00 or FF, then a lot of times you have to open the ZIF socket and move the device around a little bit back and forth, close it. Maybe there's a little oxidation on the legs or something that you have to clear. That's what I've run into. So the next thing I'm going to do is the FF button will check to make sure the device is empty. So I'm going to hit that and then press blank, and it's going to read the entire device and check to make sure that it comes back as entirely empty. All right, and it's showing us here, it says check code memory empty, and it gives us the elapsed time. That's great. We can cancel out of that. And in fact, we could also read the device into our buffer and check to make sure it's empty. Now, if you do that, you will have to reload your ROM file. But let's take a quick look. I'll show you what it looks like. Okay, so you can see that every cell is set to FF all the way throughout. That's perfect. So let's reopen our previous file here. There it is. And we're going to hit OK. So just like you have the R button to read, you have the P button to program. So we'll go ahead and press that, and we're going to tell it program. Now it's going to program and it's going to verify because we have that option checked down here on the left side. So we're going to give that a few moments to work through, get the code programmed into the ROM, and then verify that everything went correctly. I believe that it's actually verifying as it programs. I've had this step fail before pretty quickly. Like, it programs a cell and tries to verify a cell, and then it fails out almost immediately. Like, for instance, if you have a damaged chip that's not accepting the programming correctly. So the reason that we're looking at this, one of the next projects that I'm going to take on is I have some K-Pro computers here. One of them has an aftermarket ROM that I don't have a boot disk for. And so I'm going to blank a UV EEPROM and program the stock K-Pro ROM into it and install it in that machine so that I then have the ability to boot it using a standard boot disk with a GoTech that I've got installed in there, a floppy disk emulator. Now, the other thing that I have on the machine, it has two. So it has the A drive is a GoTech. The B drive is an actual physical drive that's been cleaned and re-lubricated and is working correctly. So I'll be able to dump my physical floppies into drive images. So I need to get started on that, and that's one of the reasons that we're moving along on this project. Now, of course, what you run into is the larger that the device is capacity-wise, the longer that it will take to program, usually. Like, for instance, if this was a 2764, it would have been done in a matter of a couple of seconds. But since it's a 27C801, and it's a much, much bigger device by orders of magnitude, it's going to take a lot longer to become fully programmed. Now, of course, a lot of times on these ROMs, they're read at a standard logic voltage, for instance, 5 volts, but to program them, you have to have something higher, 12 volts, 12.5, 24 volts, 48 volts. The older the EEPROM, a lot of times, the higher that programming voltage, and that's why modern programmers are not compatible with very old ROMs, is because they have no way to supply that voltage. And those ROMs have become rare enough that they're cost saving the design. they're not going to give you a device that can support all those voltages because there's not a need. There's not a huge demand for it. Okay, so it looks like on this one, it programmed, and now it's going back and it's verifying. It should be done in a matter of a couple of moments. Let's see what we come back with. Okay, great. So programming code was successful, verify code was successful, and programming is successful. So we can drop out of that. Now what I will do is I'm going to clear all my buffers, and then I'm going to read the device just to make sure that it took the programming. So let's cancel out of that, and we can see that yes, it did take the programming. It looks like everything that's supposed to be in this ROM is here. So that's perfect. All right. So that should wrap this up for today. In the next video, or the upcoming video on the K-Pro project, I will walk through the entire process of putting the ROM in the, removing the label, putting the ROM in the eraser, verifying that it's erased, getting the correct ROM file into the Mini-Pro software, and then actually burning it to the chip that we're going to use, then installing it in the machine and testing it. So stay tuned for that. Thanks for sticking around today and watching the video all the way through. And if you've enjoyed the video today, make sure to like, share, subscribe. Have a great day, and thanks for watching.